look at expressions. We looked at expressions, and we said that an expression was something that had no equal sign. So it was just like a number sentence. Something like 3x plus 4. And last week it told us what the x was, and then we had to use order of operations and simplify that. That is our expressions. Expression does not have an equal sign. This week we're going to be looking at equations. In equations, our root word being equals, does have an equal sign. It's a problem like 10 plus a number equals 15. So we have a variable and an equal sign. The difference between an expression and an equation is that an equation can be solved for the variable. And this idea that one side is equal to the other side is really handy. So for example, if we've got a problem such as 10 plus a number equals 15, we know that this side is going to be equal to this side. We just don't know. That's missing information that we need to solve for. And I know you guys have already solved it in your heads. I want to show you one of the tools that we're going to use to solve it, and it's a balance beam. Think of it as maybe like a teeter-totter. So you've got one person on this side of the teeter-totter that's a 10, one person on this side that's going to be a 5, and you've got some other thing on here that's unknown value. But you do know that the teeter-totter or balance is completely level. Someone give me a strategy to find out what that number could be. Anna?
You subtract the 15 and the 10.
So if you remove the 10 from this side and cancel it out, and then you remove 10 from this side, you're going to be left with whatever's going to balance that out, correct? I completely agree with that. If I take 10 away from this side here, and I take 10 away from this side here, that'll leave me with my n on this side, because I took that 10 off. And I take 10 away from this side, that leaves me with a 5. So n equals 5. One of the reasons that I love teaching math more than any subject ever is that in math, there are a lot of times where you get to check your work and you know if it's right or wrong. You're guaranteed to be right or wrong. That doesn't happen in language arts or in social studies. In social studies, when you have to write a narrative about Mayan ruins, it's really difficult to know if you're going to be right or wrong. Are you focusing on the right thing? Are you not focusing? Are you including everything that you should be including? In math, when you solve your equation and it says n equals 5, there is a really easy way to make sure you're right. It's exactly what we did last week. If I say that my n is 5, then I'm going to go into my calculator and I'm going to plug in my original equation. 10 plus n, and I think that the n is 5, and I hit equals, and that gives me the right answer. If I got anything other than 15, then I know I'm wrong, and I need to fix it. It is possible to grade your stuff before you even turn it in. Let's look at a couple more examples. Let's say I've got a minus 18, and we can change the variable. It's an unknown amount. Our variable can vary. Another equation, a minus 18 equals 16. How can we solve this one? Use the same ideas as the first one and apply them to our second one. Madeline? Oh, I'm sorry, Madison.
You add 8 from side.
Yeah, you're going to add 18 to both sides. In the first one, we subtracted. In our second one, we add 18 to both sides. So we can add 18 to both sides. Gives us 34. And we can check our answer. We'll do 34 minus 18 equals 16, so we know we're right. All right, let me try to stump you here. Let me do 5G equals 60. 5G equals 60. Haley? It might be, but how do I find out? Here's your hint. Here we subtracted 10. Here we added 18. That's 5 times G. So what am I going to do? We're going to do the opposite. We're going to divide by 5. So now those cancel. So our G will equal 60 divided by 5 gives us 12. And we can check to see if that's right. In our calculator, we have 5 times G. We think that G is 12, so we'll do 5 times 12. And Haley was right. Haley, how did you solve that problem?
I divided 5 times.
Did you?
Well, like, I can do that 5 times 30.
Yeah, so like you just use number sense. You're like, well, I know that 5 times something will give me 60. I know my facts well enough to know that that's going to be 12. Yeah, that's a good number sense way to solve this. A lot of these problems, like 10 plus n, you guys know that if you add 5 to 10, you'll get 15. That's what we're looking at is kind of here this process. Because there's going to be a lot of problems that we're not going to just know off the top of our heads. Let's look at one more example of these. Use what we've done so far and apply that to our fourth example. All right, Scout, walk us through this one.
Okay, so you're gonna multiply
Okay.
by like wouldn't you usually multiply by 8?
Sure.
Like it doesn't.
Why can't? Like?
Oh yeah.
Sure.
So if you multiply by 8, then P equals 8.
Yeah, and here's the reason this works. If I have P divided by 8 and I multiply it times 8, you might remember multiplying fractions that you can cross cancel. 8 over 8, those just cancel to be 1s, which makes this P over 1. P over 1 is just P, so that remains a P there. That's why those cancel out. And on this side, I've got 10 times your 8, which will leave you with 80. And we can check to make sure that that works. If you start with 80 and divide by 8, it gives you 10. So you know you're right. That is the equations part of it, but we're also going to be extending that. Just like we did last week with expressions, we're actually going to be doing a little bit of translating. Let's translate a couple different examples. Our first one, 11 more than a number is 37. So very similar to what we did last week, where we had to translate from words and put it into a expression. Now it's asking us to put it into an equation. Scout?
Are we like translating it into a number problem?
Yep.
So it would be like A plus 11 equals 37.
Agree or disagree?
Agree.
I do too. And I think the way that he wrote that was a really good way to write that. 11 more than a number. So if I have 11 more Facebook friends than you, I would have to start with your number of friends and then add 11 to it to find mine. So when it says 11 more than something, you're going to start with the thing and then add 11 to it. If I wrote 11 plus A equals 37, is that going to give me, it's going to give me the same answer, isn't it? This goes back to the properties that we talked about last week. The commutative property of addition, where the order of those numbers doesn't matter, it still gives you the same result. So now if I solve this, I can subtract by 11, subtract by 11, so A equals 26. And then I can plug it back into the original equation. 26 plus 11 gives us 37, so we know we're right. Let's do our second one. So the difference of a number and 16 is 5. The difference of a number and 16 is 5. Anybody think they got it? Tobin?
B over 16 equals 5.
Say that again?
B over 16 equals 5.
So you're saying B over 16 equals 5, like that? Now when you hear the word difference, what do you think of like difference? Like the difference in height between me and Mr. Karate is like 3 feet. So, Tobin, would you like to modify that?
Yeah.
What do you want to do? All right. So you want to change this to B minus 16 equals 5, like that?
Yeah.
You guys agree with that? Yeah, I think that works. So now what I've got to do is figure out, well, what minus 16 will give me 5, and I'm going to solve it just like we did with the equations up above, the opposite. I'm going to add 16 to both sides. And when I do that, I can do 5 plus 16. B equals 21. And we can always check to make sure we got the right answer. Plug that in. 21 minus 16 gives us 5, so we know it works.